Alright, we're going to start part 3 of the 7-8 review. And we left off on the last video with Vertex Form. Alright, we know that we have standard form of a quadratic, which is ax squared plus bx plus c equals 0. That's standard form. Alright, and that's the form we use when we're factoring, and then some other methods we're going to learn. But there is another form called vertex form. Alright, and vertex form is y equals a times x minus k squared plus h. You're like, k and h? Well, it's basically the same as x and y. Okay? Think of it as x and y. But it's not, how do I say? It's not just any x and y. It's specifically going to be the vertex. The x and y coordinate of the vertex. Alright? So, in vertex form, the k and the h is the vertex, and k is the axis of symmetry. So if you're graphing and it's already in vertex form, you don't have to do that opposite of b over 2a because they already give it to you with the letter k. Alright? Whatever's in that place represents the x-coordinate of the vertex. It represents the axis of symmetry. Okay? Now, when you're looking at this, inside the parentheses here, I call this opposite world. Alright? Because of that minus sign. Think about when you're looking, your k is going to be the opposite of that. So if it's x minus 2, then your k is going to be 2. Okay? Because it's subtracting k. Alright, so it's always going to be the opposite of that. Alright, so let's look at this. It says give the axis of symmetry and the vertex. Alright, so the axis of symmetry is going to be our k. And it's right here. And it's going to be the opposite of positive 4. So our axis of symmetry is going to be negative 4. And my vertex is also the x-coordinate of my vertex. And then h is the y-coordinate of your vertex. You don't take the opposite. This, you do the opposite. Okay? Only inside the parentheses is it opposite world. Okay? Alright, let's look at this one. Axis of symmetry, again, the opposite of negative 3, 3. So my vertex is 3. And then there's nothing out here for h, so we put a 0. Alright? On this one, axis of symmetry, the opposite, 5. And then my vertex is 5. And h is negative 4. K is negative 4. Okay. Alright. And then this one. We don't have any parentheses. Alright, so it's the same thing as negative 2 times x minus 0 squared plus 3. So if there's no parentheses, it means our axis of symmetry is 0. So my vertex is 0, and then this is your y. It's positive 3. Alright, so I love vertex form and the fact that I don't have to figure anything for my vertex. It's right there in front of me. All right, for the this one here, we're going to graph it. Axis of symmetry, I don't have to do any formula opposite of b over 2a. It's already telling me it's the opposite of 2, so it's negative 2. My vertex is 2, 7. My domain is always all real numbers. And this is going to be, since it's a negative, it's going to be going down, right? So our range is going to be less than or equal to the y-coordinate 7. All right, because our vertex is going to be a maximum sitting up top. If it was going upward, my maximum would be, my vertex would be a minimum, and my range would be y everything greater than 7, okay? So this is determined by whether your vertex is a minimum or a maximum. And you can take your vertex and put it in the center, and you can go ahead and plug in the numbers, put the equation in your calculator, go to your vertex, and then go forward and backwards, get your y-coordinates. Or if you don't want to use the calculator, you take up a little more time, you can just plug these numbers in for x into your equation and get y. Alright, so I'm going to go ahead and graph them. I'm going to do my vertex first. It's negative 2, 7. So I go to the left 2 and up 7. And then my negative 1, 6. And negative 3, 6. And see, it's symmetrical. That's your axis of symmetry. So that's why everything is the same distance from the center on each side. And then we have 0, 3 here. And then across at negative 4, 3. Same distance from your center, right? So basically, if you get one side of numbers, you can graph the other side. Okay? Alright, let's go to the... Alright, let's talk about transformations. Transformations. Alright, the most simplistic quadratic equation is y equals x squared. This is known as the parent function. Okay? A transformation is a shift it's a shift. It could be a vertical or horizontal to the graph, or you could shrink, not shrink, not shrink, it's an S word, stretch. Or you could stretch or compress the figure. Okay, and we'll talk about that. Alright, so when you're looking at a graph, this graph is y equals x squared. Okay, this is the parent function. And if you look at this equation, they've added this plus 2 here. Alright, now that plus 2 is really opposite 2. And it's saying that your x coordinate of your vertex is shifted to the left 2 times. Okay? Because if my vertex, my axis of symmetry changes from 0 to negative 2, it moved to the left. So my transformation is that it moved to the left 2 units. The whole graph shifted. Alright, and if you plug in these numbers, you can draw your whole graph and see that the graph itself shifted. Nothing else changed, it just shifted over. Okay, but we're not going to take the time and graph all that because we can just look at it and see. Alright, looking at this one, I don't have any parentheses, so my vertex, the x-coordinate stayed the same. I still have the same axis of symmetry, so it's not shifting left or right. However, my y-coordinate is 5 now instead of 0. So my vertex went here. So it shifted up 5 units. Okay, it didn't go left or right. It just shifted up 5 units. Alright. This one, again, no parentheses, so 0 is still my axis of symmetry. Alright, it's still 0. However, my y-coordinate now is -7. So my vertex has gone all the way down here, from here to here. Now, my A is 3. So if A is greater than or equal to 1, then you're going to stretch your graph. If A is greater than 0 but less than 1, in other words, it's a fraction, then you're going to compress. Okay? If it's 1 or greater, you're going to stretch it like a rubber band. You're going to stretch it out, and it gets skinnier. If it's a fraction, then you're going to compress it. You push it down, it widens. Okay? So on this one, we had a stretch, because it's a whole number, it's greater than or equal to 1. We had a stretch of a factor of 3. Okay? Stretch of a factor of 3. So it's kind of like when we were looking at quadratics and we see a quadratic well, I don't have a table to look at on that one. I'm getting off track. Let's stick with what we're doing here. Stretch of a factor of 3. It also shifted down 7 units. Alright? Now, if I was to plug these in, let's just plug in, let's see, my vertex is 0, -7. So let's just plug in 1. So that would be 3 minus 7 is -4. If I plug in 2, 3 times 4 is 12, minus 7 would be 5. So let's plug these in. 0, -7's here. 1, -4 is here. And then 2, 5. 2, 4. It's right here. Alright, and it is still symmetrical, so it's the same thing, 1 unit over. So now my graph looks like this. So see how it's skinnier than the original parent function? It stretched it out. Okay. Alright. Now, ooh, look at here. This one's got everything going on. Alright, first off, we got a negative. Alright, a negative means that it reflected are flipped over x-axis. Okay, so it's going to reflect. It's going to flip over the x-axis. All right, the 1/2, that's a fraction. A is a fraction, so it compressed by a factor of 1/2. All right, we have a horizontal shift. Opposite world is +3, so it went to the right 3, and it went down 2. So let's look at the graph here. 3, -2. So 3, 1, 2, 3, -2. So my vertex moved over here. Let's do this one blue. And let's plug in some numbers. 2, 1. So if it was 1, 1 minus 3 is -2 squared is 4. -1/2 of 4 is -2 minus 2 is -4. And then if you plug in 2, it'd be -1. So -1 squared is 1. So 1 times -1/2 is -1/2. So this is -2.5. Okay, so at 1, it's going to be -4 here. Oops, blue. Here. And since it's symmetrical, it's going to be over here. And then 2 is -2.5. So here and here. So your graph's going to go and look something like that. Okay, so it's squished out a little bit. It shifted to the right 3, and it shifted down 2. And it flipped. Alright, so to reinforce what we know about transformations, did I get my letters mixed up? Yeah, I get my H and my K mixed up all the time. Follow the alphabet. H comes before K. Okay, so you might want to go back on that other page. This is H, and that's K. It still does the same thing. I just got my letters. Alright, H is your horizontal shift. Okay. A plus sign means it shifts to the left, and that's because it's opposite world, right? A minus sign, if I have a minus H, it's going to shift to the right. K is the vertical shift, and plus shifts up, and negative shifts down. If A is negative, the function is reflected across the x-axis. If A is greater than 1, then it's a vertical stretch. If A is a fraction, then it's a vertical compression. Okay. Alright. Here it says write an equation to represent the function with the described transformations. Alright, so this one translated 2 units to the right. So the only thing we have is our A's not changed. So it's to the right. So this inside here is opposite world, so it would be -2 squared squared. Okay, because on the outside, on real world, right, going to the right is plus. But inside the parentheses is opposite, right? So it's minus. And this one says it went up, so your parent function is this, right? But we want to shift up, so we're going to add 5. Translated 3 units to the right, 2 units down, and reflected over. So A needs to be negative. And it went 3 units to the right, which is plus 3, but in opposite world, it's minus 3. And don't forget your square there. And then 2 units down, so minus 2. Translated 1 unit down, reflected over the x-axis, and compressed by a factor of 1/2. Alright, so it was a negative because it's reflected, and A changes to 1/2 instead of 1. And we didn't go left or right, so this is going to be an x squared. And it shifted down 1. Okay. 5 units to the right and stretched by a factor of 4. So A is now 4. And it was 5 units to the right plus 5. So in opposite world, it's minus 5. And then it translated over the x-axis. So it's going to be the parent function, but it's going to be negative x squared. Alright. What are the roots? What are the roots? And it says to sketch an equation. Alright. So if I'm doing the roots, this, I know I can factor -5 and 4. So what are the factors of -5 that add up to 4? Well, I would say 5 times -1 is -5. 5 plus -1 is 4. So my factors would be x plus 5 and x minus 1. And if I set those to 0, I'm going to get x equals -5 and x equals +1. Remember, your solutions are the opposite of these. Because you set these to 0, you solve for x, you get the opposite. So if I had a graph, that means my graph is going to cross at -5 and it's going to cross at 1. Also, my A is positive, so that means my graph is going up, right? I can also see my vertex is going to be the opposite of 4 over 2A, so -2. And my Y would be, let's see, that would be 4 minus 8 minus 5. So it'd be -9. So -2, -9's down, would be further down. So you're going to be looking at a graph, something like that. Okay. Alright, so if we look at this one, alright, this one, the factors of 9, we don't have a B, so it'd be 0 here, right? So it'd be x plus 3. Oop, that's not going to work. That's, I'm remember doing this in class. This had the wrong sign on it. That's supposed to be a negative. I typed the problem wrong. It's -9. So -3 times 3 is -9. -3 plus 3 is 0. And that's a difference of squares, right? So it's one's x plus 3 and the other one's x minus 3. Because they're both perfect squares. So it's x equals 3, x equals negative 3. My axis of symmetry is 0. So my vertex is 0. If I plug it in, it's a negative 9. So 3, negative 3, and 0, negative 9. So it's going to look something like that. Alright, so what we got on vertex form, let's look at discriminant. If you remember, discriminant is part of the quadratic. The discriminant tells you how many solutions. And to find the discriminant, it's the part that's inside the radical of the quadratic formula, b squared minus 4ac, right? If the discriminant is greater than 0, then there's 2 solutions. So if it's positive, it's 2 solutions. If it's 0, then there's 1 solution. If it's a negative, less than 0, then there's no solutions. Okay, so how many solutions does this have? So this is A, B, and C. So b squared, so 5 squared minus 4 times A times C, and it's going to equal negative 4 or negative 71. So there are no solutions because my discriminant is a negative number. Alright, the points at which the quadratic equation intersects the x-axis are referred to as, we have 4 names for it. Well, when you intersect the x-axis, that's an x-intercept, right? If you're graphing it, they also call those the roots. When you're factoring, they're called the solutions. And if you're solving an equation, they're also called the zeros. You can put a 0 in for y, and it'll give you your x. Okay? Alright, I kind of gave you some little reminders here exactly how to solve a quadratic by factoring. Alright, we did factoring earlier in this package. I believe it was on the last video. You put A times C. We're looking at this equation. This would be negative 10, and B would be 3. So we're looking at the factors of negative 10 that add up to 3. And if you look at this part, we've listed out the factors, and we see which of those, if you add them together, would give you 3. And we'll see that this pair of factors, negative 2 and 5, if I multiply them, I get negative 10. If I add them together, I get positive 3. And we're dividing by A, which is 1. So those are the factors. So my binomials would be this. So this 2 binomials here would be the factors of the equation. Alright, those are the factors of the equation. Just like negative 2 and 5 are the factors of negative 10, this is the factors of that equation. The solutions are going to be the opposite. X equals 2 and x equals negative 5. And it's always the opposite. If I was to set each of those binomials to 0 and solve for x, this is what I would get. Okay, it's going to be the opposite. Let's say that you have the binomial One of them's 2x plus 3. Alright, if I set that to 0, it'd be 2x equals negative 3, x equals negative 3 over 2. When you had your x, you would have had positive 3 over 2. 2 goes in front of it, 3 goes behind it. Okay. Square root method. Square root method is usually you use it when there's no b. So if you have like y equals x squared plus x, okay, there's it's not x. Whenever you have x squared plus c, alright, you're going to isolate x squared. So in this case, I would add 49 to the other side or both sides. And then take the square root to get rid of that square. So x equals plus or minus 7. Alright, remember, a positive number always has two square roots, a plus and a minus. Okay, I'm going to stop here. Looks like this video, we're going to have 4 videos on this review. Maybe 5. Oh, we'll see. But I'm going to stop here. This one's getting a little long. Alright, thanks y'all.